Hello, grade 11. We are back again with vectors in 2D, tackling exam type questions, part 3. Now we have question 2. It says 2.1, define resultant vector. Now, resultant vector is a single vector that has the same effect as two or more other vectors acting together. Do not forget it. 2.2 says three forces F1, F2, and F3 act simultaneously at a common point O as shown in the diagram below. Now we can see that from the diagram. F1 is a 3 Newton force acting at 90 degrees and F2 is a 8 Newton force acting at 0 degrees. F3 has an x component of negative 4n and a y component of negative 3n. So we've been given the components for F3. No need to calculate them. So 2.2.1 says calculate the magnitude of F3. Now we are looking for the magnitude of F3. So the first thing we are going to do is try to resolve this with its components. Now we have F2, that's 8 newtons. We have F1, that's 3 Newton. But remember, we've been given the components of F3. So the y component will go downward like that. And it's negative 3 newtons. And the horizontal component will go to the left like that. And it gives us negative 4 newtons. So this is Fx. Now we have it resolved like this. Now they say calculate the magnitude of F3. You will understand that F3 here has the same effect as these two components, right? So now if we can just do this, remember this is our Fx. So let me do it like this. Remember, this is my Fx moving all the way, negative 4. And then this is my Fy all the way down here, it's negative 3. So if I can try to close here, you can see that the F3 fits perfectly in here. So that means if we want to get the magnitude of F3, we can use our Pythagoras theorem. And we get the resultant force, which is F3 in that case. Let's calculate. So meaning to get our F3, we will have the x component of F3 and the y component of F3. And now we have negative 4 square plus negative 3 square. Now adding that together, we get 25, and then the square root of 25 is 5. That means the magnitude of F3 is 5 newtons. Nice. Now let's check 2.2.2. It says calculate the magnitude and direction of the resultant force acting at point O. Acting at point O. Now we know we must first calculate the net horizontal component and the net vertical components or forces. So starting with our components or our net for the horizontal forces or components, we have Rx, and then you will note that the ones that are horizontal are your negative 4 and positive 3 this side. So we have negative 4 plus 3 equal negative 1 Newton. Now we know the negative 1 indicates that it is going to the left. Now let's calculate the sum of the vertical. For some of the vertical, we have 8 going upward, and then we have -3 going downward. So that means we have 5 newtons, and the direction is upward. Now to get the net, let's try to draw the situation in here. We have -1 going that side, and then we have 5 newtons up, right? So if we can close here to form a hypotenuse side, this is the side we'll be looking for, F-res. Now to calculate, we say F-res or F-net, the way you like it. Then this the Fx net square plus the Fy net square. So the total of your horizontal square plus the total of your vertical square. Now the total of the vertical was -1, then square, plus the total of the vertical was 5, then square. You punch that in your calculator, you have 5.10 newtons. But remember, we are not done. The question said magnitude and direction. So now for our direction, let's put our angle just between the x-axis and the hypotenuse. So we have our angle here. Now you can see that we have the opposite side and the adjacent side, meaning the trig ratio that we can use here is tan theta. Now tan theta is equals to opposite, which is our Fy net, over adjacent, which is our Fx net. Now what is our Fy? We calculated our Fy to be 5. And then what is Fx? We have 1. So it's -1, but remember, when calculating the angle, we substitute it as a positive. Then tan theta is obviously equals to 5. Then if we want theta, it's equals to theta equal to tan, inverse of tan, 5. Then our theta is equal to 78.69 degrees. Then obviously that have to be from negative x-axis. So that's coming from the negative x-axis. As you can see, the shape of the graph here is from the negative x-axis. So this one is positive and this one is negative. So it's coming all the way like this in a clockwise direction. That's from the negative x-axis. And that's how you could have solved the question. Awesome.